All right. Good morning, everybody. Welcome to our MSE 100. So these are the set of pre-recorded videos for our lecture. So the course itself is going to be kind of like split. So we'll go over the overview of the course in a bit. But the main course, actually, we are going to be focusing on two aspects. So essentially, we want to make sure that you guys are very familiar and very comfortable with using SolidWorks, so which is the 3D CAD software that you use. So hopefully it'll become second nature by the time we are done with this course. At the same time, you should also be fairly familiar with creating hand drawings really quickly. So the reason this is important is if you go and then if you wanted to convey your design intent really quickly to your colleagues, so you want to basically make sure that you can actually kind of create a quick sketch and it actually kind of represents an engineering sketch. What we mean by that is any details that you actually communicate are actually standard notations so that the person who's reading the sketch is able to kind of follow what's happening. And then once you actually get into this engineering mindset, you can actually look at different components of your drawing, and then your mind will kind of like put all of this together and then kind of like really quickly construct a 3D object. So this is the reason we'll also focus on creating what we kind of call hand drawings, where you kind of create the drawings and the sketches manually. But if you're actually going to be sending out this for production and you wanted to do more analysis, you should also be familiar with actually creating a 3D rendering of the part or the object using professional grade software. So when you're going and then maybe doing a co-op, and then later on if you're continuing on mechatronics and then you happen to focus on some aspect of design, it's really important that you are able to communicate and then create like 3D parts which you can kind of do more interesting stuff. And that's the reason the course is going to be kind of like it'll appear like as though it's split, but then eventually we'll kind of bring them together where you would kind of like go smoothly from the 3D drawing onto the 2D part, and then kind of like go back to the 3D software, and then you should be able to kind of like once you look at the part, you should be able to kind of like mentally quickly go from one to the other. So just don't be super afraid or freaked out about the course itself. Most of you are going to be first year students, so we are aware of the level, and then we'll make sure that you're kind of like guided through. Obviously, we don't want to spoon feed all of the information to you because now you're actually transitioning into a college environment where you're expected to take a little bit more charge of your education and then take more initiative. But at the same time, we're not going to throw you off the deep end. We're still going to guide you through the process. So as such, what will happen is we'll do some kind of like I'll give you an overview of the 3D software as well as the drawings here. And then at the same time, so we'll have the TAs help you a little bit. So we'll set up office hours and do all of that stuff. So with that, let's look at the. So what I'm planning to do is I'll basically give you kind of like a blank template of the course, which you can kind of like fill in, and then as we go along, you can kind of like follow through about what is happening. So here is the sheet you hopefully excuse me, printed out already. So the learning objectives for this week's lecture is going to be kind of like a quick introduction to the course itself, and then we'll go over the SolidWorks software that you're going to be using. And then these are going to be the topics. So we'll kind of cover the brief introduction to the course, which I've partly done already. And then we'll go kind of over kind of brief review and some introduction to SolidWorks. And then we'll kind of go into SolidWorks where we'll talk about the object structure and then how things are set up within SolidWorks. And then we'll talk about constraints in SolidWorks. And then once we are done with that, so what we'll do is we'll basically look at creating 3D objects within SolidWorks and then see how the whole thing actually works. So let's look at what we're going to be doing in the course. Just as a quick reminder, so make sure you actually get the L shaped. So we're going to be using that shortly. So make sure you look at the help and then kind of like put the L together. So that's going to be helpful in visualizing the drawings and so on. So essentially, like I mentioned, so traditionally what has happened is engineering drawing or engineering drafting used to be what's known as a hand drawing. So essentially this will help to quickly visualize the shape. So we need to make sure that we are fairly aware and also that if you have a kind of like a quote unquote old school drawing or some printed drawing, you should be able to kind of look at the drawing and visualize how the shape is. The other advantage is the engineering drawing or the 2D drawing also are kind of technology agnostic, in the sense you could kind of like upgrade the SolidWorks to the latest version, and then you can still look at the old drawing and then see how the thing looks. You'll actually notice one of the annoying things with the software, particularly SolidWorks, is there is compatibility issues. Basically, you want to make sure that you have the same version both in your school and your home computer, otherwise it kind of messes the whole thing up. So I kind of, when you do install SolidWorks, make sure you have the same version that you're using in the school computers. But then coming back, so all modern systems use what's known as a 3D CAD software. So this is kind of like the almost like a pseudo standard. So hence we have to kind of teach both. But what happens is with the 3D software, the advantage is once you have the part within, say, SolidWorks or other equivalent software, so if you have Pro-E, CATIA, what have you, you can actually quickly export it to analysis software like, say, ANSYS, or do more complicated stuff, actually have it 3D printed and do all of that stuff. So this is actually really useful. And so this is where we kind of like are looking and then focusing on both of this. Coming back, so what is engineering drawing? So engineering drawing is essentially standardized technical drawing which is used by architects, designers, and so on. So it's kind of like really nice. So I'll put a link to the videos here. So it's kind of like really easy to visualize parts. So if you have a 3D drawing, you can kind of like simulate your hand, and then if you wanted to simulate how the assembly would be, so you can kind of like simulate your hand to see if you have enough space to kind of like go inside the part. If you can put a tool, you can look at clearances, which are a little bit more difficult to analyze in 2D. So for instance, if you have a part one below the other, and then you're looking at, say, the top view, so you're not sure if they're hitting, but then if you have a 3D view, so you can kind of like rotate and then see what the gap is going to be, which is not impossible with the 2D drawing, but it is just a little bit more difficult and kind of like putting it together. So with that, so I'll put the link to these videos here. So these are actually really nice. You can pause the video here and then go back, look at the Chevy engine, which is done in a 3D software, animation in a 3D software, and then you can come back and continue looking at this. So let's look at the workflow. So we'll actually start looking into SolidWorks. So before I actually open up SolidWorks, since I don't want to be switching back and forth, we'll look at the basic workflow that will be used in SolidWorks. So I'll go over this stuff, and then I'll kind of switch to the windows for SolidWorks, and then I'll show some of the stuff here, and then we'll come back and then look at more things on the sheet of paper. So essentially, SolidWorks has different types and layers of stuff that's used to build up your model. So on the base is what's known as a reference geometry. So this would be similar to your kind of your X and Y axis, and you're setting up the origin. These are things that do not directly make up the part. So you don't really have an origin. So if I take essentially an engine block, so you can't really point and then say this is the origin. But nonetheless, if you're constructing the engine block, it's really helpful if you have a starting point for your origins, if you wanted to make different shapes, and then also for all of your X, Y coordinated points to have some starting point. So you can think about the origin. Similarly, you can think about the essentially the planes, all of the other stuff. These are called the reference geometries. So these are really helpful to actually construct the shape, but they don't actually form the object itself. So the next thing we'll build it is, so your kind of your reference shapes are kind of the baseline, and then you start building on top of each other. So on top of the basement, quote unquote, of reference geometries, so you have sketches which are going to be similar to your 2D drawing, and then you kind of like manipulate those 2D drawings, essentially pull them out of shape, out of plane, or rotate them and do all of those things so that you can actually create your 3D objects. So that, and then finally will be a 3D objects. So the way we would actually build them is the basic set of reference geometries would already be given to you. And then what you do is you essentially kind of like build kind of like coordinate planes, additional planes if you want them. And then once you have that, what you typically do is use them to build your sketches, and then you build your 3D objects on top of it. So essentially your workflow would be typically you create a sketch with all of the tight dimension control on a planar surface, and then once you do that, we can use that to build 3D objects, and then we'll do different things to create the 3D objects. So on the bottom of this page, so if you look at, it kind of gives you the different things that are there. Maybe let me switch to the SolidWorks presentation really quickly, and then you can see what I mean. So when I open SolidWorks, this is how it's going to look. So I can kind of, so I have the thing set up so that it shows the keyword logger over here. And so I can kind of look at the screen, and then what I do is I can go to file, and then if I go file new or control N, it's going to open up a new screen that I can use. And then here is where I would select all of the things that I need to. So what I'm going to do is I'm going to create a new part. So essentially I'm going to create a new part, and then we're going to click OK. So I actually opened up SolidWorks before, but the very first time you open it, it will give you the option of units. So I actually recommend that you select millimeters and then ANSI standard. So that's going to be millimeters and ANSI standard. So you can change that, just that it makes it a little bit more difficult later on in the design process. So anyway, so once we have this, so we're going to click OK, and then SolidWorks is going to open up and then show us the basic layout of SolidWorks. So if you look, there are a few, essentially the screen is divided into three parts over here. So here is where all of the operations that you have done shows up. Here is kind of like different properties. If I click on one of these and then say edit or click properties, it will kind of open up the screen, and then some of the other properties will kind of show up over here. So once you do that, this is where your main object and where you're going to create your actual object. And then so what will happen is this is the plane that you have. So essentially you have three planes. So what you're actually looking at is kind of like a 3D representation. So if this is my right hand, so you're kind of looking at a 3D representation kind of and a nice, essentially kind of on the edge. So you have the front plane. So I can actually click control and then click on the other ones, and then so these are the three planes. So right now they are automatically hidden, so I wanted to show you the front plane, just the front plane. So I click on the front plane. I need to hit escape a couple of times, and then when I click and say show, it's going to show me what the thing is going to be. So once you have this, what I can actually do is I can click and then click the different aspects of it, and then I can click on the top plane, and then I can click on the right plane. So click and select all of this, and so if I go back to my presentation window, so you'll notice that essentially, so if I go to the next screen, so these are the three things that are assembled together. So you have the front, the top, and the right plane together. So if you take two planes on the intersection of two planes, what you can have is you'll basically have a line which you can use as an axis, and then you can have two axes intersect at a point, and then you can use that as a point. So those are different ways you can actually construct additional options and additional reference geometries. So let's kind of take a look at it and then see how that comes about. So I'm going to switch screens over here. And while we're at it, you can actually look at the toolbar customize, and then like you can basically right click, and then you have a separate menu that shows up, and then you can actually use essentially like this menu over here. So you can actually quickly customize and then do more stuff with it. So let's see how that actually works. So I'm going to pull up SolidWorks. So I've just moved my camera out of the way, and then here is where you're going to see at the right at the bottom of the screen. So you're going to see my keystrokes. So essentially, so what I have here, so if I kind of like right, if you remember, so I can actually right click, and then if I drag the mouse one way or the other, so I'm going to get the different options. So right now the only options are there, because I'm in a simple mode, is to essentially like change the orientation. So if I can actually also change the orientation by using the mouse key. So if I go Control 1, this is the front view, Control 2 is back, Control 3 um, is the other view. I'm actually holding Control, so Control 4 is the right view, Control 5 is the top, and Control 6 is the bottom. And then we have Control 7 is back to the original view. So it's just saying I haven't saved the document in a while, so that's okay. So we have this. So let's see if I actually want to customize the number of options I get in the right click. So I want maybe more of these. So what I can actually go do is I can actually go to either like so there are a couple of few ways you can actually do this. So like if you look at this, so I'm saying tools, customize, and then right click, so you can get that value from there. So let's see how that works. So I go to settings over here. So the reason we are having a little bit difficulty finding that option is because SolidWorks actually likes to play a little bit of hide and seek with us. So what I'm going to do is if I kind of go to the right top here and then click on this, it actually shows me all of the menu options. So I typically like to kind of expand and then click on this pin, which actually keeps the menu always visible. And then now I can actually go to tools, and then I can go figure out where the options and customize is. So you actually have more commands over here, but we're just going to click on customize over here, and then you can kind of click on the mouse gestures over here, so it can tell you what are the commands that are available. So if you go from 4 to 8, so you get like more options. We can potentially go to 12. Um, you can give it a shot. So just that the menu options might get very crowded, and it'll be rather difficult for you to kind of like figure out the options. So you need to be precisely selecting these values for you to actually get those options. You can also change what shows up in the different context menus. So I personally prefer it to be about 8, which seems reasonably okay to manage. And then if you click OK, so you're going to get that, and then you go right click, and then you get these options over here. And then if we go to Control 7, I end up with the original option over here. So as I mentioned, right now I have the front plane visible. So if I wanted to get rid of that, I can right click and then click on this option over here, which essentially hides the menu, excuse me, hides the front plane. So I can actually add more reference geometries. So if I actually click on few objects, it gives me like a context menu. So I can create a sketch when I select a plane. If I select two, so I can make them visible or invisible. So if I wanted to insert more reference geometry, so what I would actually do is go to reference geometry, click, and then if I click on axis, since I have the top and the front plane selected, it's going to ask me if I wanted to do the axis as such, and then it gives me the different options over here. Right, so this is what you can actually do, where you can fiddle around and then play around with the options menu over here. So let's say OK and then see what happens. So notice that now I have an axis over here. So if I want to rename it, actually if I want to delete it, I'd right click and then delete it, or if I want to do something else, I can do that. If I want to rename it, I have to click and then wait for a bit, and then it gives me the option. So right now this seems to be oriented along the X, so we'll maybe call it X axis, and then you get that corresponding, um, excuse me, corresponding axis named on your screen. So let's get back to our the notification we are doing. So essentially, if I go here, so this is what we discussed. So this is the SolidWorks window. So I just have this as a backup over here. So I personally prefer to actually have it locked in by clicking on the pin. And so you can actually click on the new menu. That's what we did. So we open this part and then we get this option over here in SolidWorks. So you can actually enable and view all of these windows, front plane, and then you can create a sketch to actually add a new sketch. We also looked at customizing the menu option and then doing that. So the next thing we look at is actually creating a sketch. So let's look at how the steps that you'd use. So if this is the sketch, once you click on the plane and click sketch, it'll kind of open up this option. And then if you click on the option over here, so you can kind of like zoom in over here. So it gives you different options over here: line, circle, um, um, excuse me, uh, equation driven curves, and then rectangles, squares, and like all of the other shapes that you might actually think about. So let's look at SolidWorks. So I'm going to click, so imagine I want to create the sketch on the front plane. So I would click on the front plane. As soon as I do that, it opens up a context menu right above. So here I'm going to move the mouse. It gives me the hint, and then I can click, and then it creates a sketch. So you notice that the orientation of the plane changes, and then you have a couple of things here. So this is the axis. So this tells you how your screen or the scene is actually oriented, and this is kind of the axis corresponding to the front plane that you're drawing on. So you also notice that things have changed on the top menu over here. So this is the context menu that shows up. For some reason, if there's an issue, what you do is kind of click on the sketch over here, which will bring up the corresponding menu over here. So if I move the mouse, it gives me a hint, and it also tells me like it's a line. So if I move it further, it tells me there's a circle and so on. And then it gives me a shortcut that I would use quickly. And then the thing you would notice is beside all of these, there is actually a smaller drop-down menu over here. So if I drop down, it gives me more options for the lines, midpoint line, and so on. So we'll see what all of these are in a bit. Similarly, for a circle, you have different options. If I move the mouse over here, this says it's going to be a spline, where it's kind of going to be a spline is a smooth curve between multiple points. And then if you drop down, it gives you different options here, different styles of the splines, as well as equation-driven curve. So here you have the rectangle. So if I click down, it gives me corner rectangle, center rectangle, 3-point rectangle, and then 3-point with center, and then parallelogram. So different variations over here, and then here drop down. So this gives me the different options for slot. This would be um, the next one would be the arc. The one below that is polygon. We already looked at spline, so the next one is ellipse, and then the one is sketch. So this is the basic creation, like the commands you would use to create. So for instance, let's just look at some fun example. So let's look at all of these. I want to create a line. I can either click on this, or I have the option of typing just L. So let's see what happens if I type L. So now it's kind of, you notice that there's a pencil that shows up with the option of drawing a line. So here it gives me the different ways I can quote unquote constrain the line. So what do I mean by that is I can restrict the degrees of freedom. So for instance, right now it says as sketched. What that means is if I kind of create a line like this, and then as I try to move, it's going to be along the orientation I actually create the drawing at. So if instead I basically create horizontal, then irrespective of what I try to do, the line is always going to be horizontal. And notice that as soon as I go very close to the origin, it actually draws a dotted line, and then it says, hey, it looks like you're very close to the origin. Do you want to make sure that the line is limited by the origin? So that's the additional constraint it looks at. So we'll see what these constraints are in just a little bit. So let's hit escape again, so that gets rid of this command. So do L line, now as sketched. So I draw the first line, notice that I can continue drawing more lines, do all of that, and then notice that as I get close to this, it's creating a yellow highlight. It's wanting to close the figure because it's assuming you probably normally want to do that, and then you close the figure, and then now it gives you a closed figure over here. You can kind of like play around with the other options, but I'll just show the more interesting features over here. Um, Here is the rectangle. So here you can either do as a corner rectangle, so where you pick two corners and then do this. You can do 3 points where your rectangle is kind of oriented in an arbitrary direction. You can also do essentially like a parallelogram, which is no longer parallel. So you do this, and then if you squish, it creates a parallelogram, which is kind of like a slightly different shape. And then you can look at all of the other equations over here. So this one is known as a fillet, which is kind of more interesting. So if you look at a lot of the parts that we have, so for instance, if I look at my phone over here, let me pull that up. So if you notice, the phone is no longer, actually I don't want to show you my credit card. So the phone or even the credit card is no longer having any sharp edges, right? So essentially, if you look at this edge, so it's kind of like smoothened out. Similarly, this edge is smoothened out. So if you look at a lot of the examples around you, so you notice almost all surfaces actually have like a smoothened edge. So this is known as a fillet. So we'll come discuss more about this in a bit. But this gives you an option because you're going to be using fillet fairly commonly, very regularly. So it gives you an option to quickly create the fillet. So in order to do that, so what you do is you'll click on this fillet tool, and then you can click on this corner over here, and then it automatically picks up the fillet and then creates a fillet of a radius 10 millimeters. So fillet would be like a smooth, like a semicircle over here. And then if I say OK, it just cuts it and then creates a fillet over there. So that's something you would very commonly use. So there is a special tool for actually creating fillets. So this actually brings us to a nice tangent regarding sketch manipulation. So these are the functions that are available. So which is on the next page, at the bottom of this page, essentially, where we say we can trim, where you kind of like either like trim, it would also include extend, where if you have line segments, you notice that you need to make it a little bit longer or a little bit shorter. You can do that. And then you can convert entities to reference. This is mostly useful for 3D drawings. We'll get to it in a later point. We can do an offset or a mirror, and then we can do patterns, either linear or circular, or kind of repeated patterns. So let's kind of quickly look at how you do this. So let's switch back to the screen over here. So this is the sketches we have. So imagine right now. So let's look at the trim example. So imagine I kind of created one line over here, and then I happen to create another line over here, and then I notice that I want to get this line to all the way here. So one way to do it is to kind of grab hold of this point and then extend it all the way. So there's an issue of doing that. You might actually change the orientation of a line. So in case you didn't want to do that, so what I can actually do is I can click on this trim extend option. So you can either like trim the entity or I can extend it. So let's do extend first because my line happens to be shorter. So it notice that as soon as I click on it, it gives me an orange guide saying that, hey, I wanted to take this line all the way to the other line. So I'll like do that and then it extends it. So we can do the same thing with trim. So let's say I happen to have this line a little bit longer. And then what I can do is I can click on trim. So as soon as I click on trim, it gives me the option of what's known as a power trim. So this is the default, so we'll keep it at power trim and then see what it actually does. So notice that I'm actually holding my mouse down and then it kind of draws a line of how things are going to get cut. So if I go over this point, so now it figured out it can actually cut related to the other line. And then if I do this, this gets deleted. So if I kind of click over here, this part gets deleted. So if I click on here, this part gets deleted. So I probably didn't want to do that, so I can undo So it does kind of, because you did all of it in the same operation, it undoes anyway. So does removes all of the operations. So in case I just wanted to get rid of these two, so I can use power trim and do this, and then this is a little bit extraneous. I can cut this and then cut this, and then this one I probably don't need, and I can kind of quickly come up with a shape. So we already looked at creating fillets. So there's another option which is known as chamfer, which is kind of like creating flat edges. So let's do a chamfer at the other edge. So now it does a 10 millimeter. So if you zoom in over here, so so this is the chamfer over here. So if I double click, I can actually change the values. So right now it's 10, and then I say OK, and then that's what it's done. So the next topic we're going to be looking at is what's known as constraints. So the constraints, so if you look at what's happening, so if I have a line here and I hadn't constrained it, so it'll kind of like move haphazardly, right? So I can just move potentially just this line over here and this arc over here. But typically if you have a closed figure, so you might want to move maybe the whole thing maybe deforms, so you don't want the parts to coming apart. So in this case, what you do is kind of like have a way of linking or ensuring that maybe this edge of this line is always coincidental with the end of this arc, or any other combinations you can do. So essentially, constraints are logical links between different entities in a given sketch. So there are different constraints you can actually do. So you can do what's known as dimensional constraints, so which kind of figures out or limits the length or the size. You can do what's known as and so dimensional constraints would include the length, kind of the angle or the orientation, or the distance. So if you have two lines, so you can figure out how far. So you move the lines, they always move together. You can have positional constraints, so where I can say it's coincidental. So I want maybe my index finger on one to be coincidental with the index finger of the other. So if I move one hand, the other one moves along. And then you can have collinear point on the line, and then you can also have geometric constraints, so where you said it's going to be parallel, perpendicular, or tangent to be like if you had a circle and then it's going to be kind of like on the edge of the circle. So those would be constraints that you have. So you can do another constraint which is known as a fixed constraint. So like you can actually potentially do something known as a fixed constraint, where you're saying that the whole sketch doesn't really move or doesn't do anything. So it's kind of like in place. So let's look at the sketch that we just created. Uh, this one actually seems to have too many parts or too many things in there. So what you can actually do is exit this. Now I see the sketch. So what I can actually do is maybe if I didn't want the sketch, I can delete it, or I can just hide it for now. Let's just maybe hide it for now. And then we create another sketch, maybe this time on the top plane, and then click on the sketch. So now you notice there's a little bit of an issue that the orientation isn't correct. So what I can do is right click and then say make normal to view, and then now it brings the correct orientation for me to create the sketch. So we're going to look at the different constraints that we are talking about. So essentially we look at we quickly look at dimensional constraints. So there are more things involved in the dimensional constraints which we'll come back to, but we'll look at all of these constraints in just a little bit now. So let's look at this. So imagine I have this line. So if I wanted to kind of create the constraints, so I need to have the entity first. So notice that when I look at the line here, so there are a few things that's happening here. So the first one, let's look at just with one line to do dimensional constraints. So the way you would set the dimensional constraint is click on the smart dimension, which actually adds a fixed size to it. So click on this, and then here, so now this is kind of ensuring that the horizontal length is some particular value. So for instance, if I wanted to make it 120, and then say enter. So what that means is if I try to move this, I have to hit enter a couple of times. So if I want to move this, so if I try to move this point, so notice that the horizontal length is kind of fixed. So if I try to move this point, it gets longer and shorter in the y direction, which kind of changes the effective length, but the horizontal length is always fixed at 120. So this would be one type of dimensional constraint. What I can also do is I can just move the line here. I can actually put a smart dimension, and then I can do a vertical constraint, which will fully constrain, which will kind of like define all the lengths. I can also ensure if I wanted to fix the length of the line, so I need to basically make sure that I move parallel to the line. So if you have an issue, so you might have to move the mouse a couple of times till you actually get it the dimension to be parallel to the line. So if I did that, I get this value. I can change this. Just notice that due to the rectangle, this being a triangle, the number I enter needs to be larger than 120. So maybe I make it 145. And so it changes the orientation accordingly here. Uh, and then let's move this line back to the screen. I can actually move the position of these, so that's not a big deal. So now the sketch or the line sizes have been defined. So I can kind of, if I try to move the point, essentially what happens is that the entire line moves. So let's look at the next one, which is distance constraint. Um, so to do the distance, if I need to draw another line, I need to have additional constraints. So let's not do that for now. But I can basically set the distance of this point from the origin over here. So the way I would do it is click on the smart dimension again, click on this point and this point, and then again I can kind of basically do a horizontal. There isn't really a vertical constraint. There is. It's a very small vertical distance. And then I do, right now I can just do the horizontal constraint and just set this to 100. So it moves all of the entities corresponding to it. So now the only thing I can do is kind of like move the point vertically. So if I wanted to do a vertical constraint as well for the position, I can do that. Click on here and here. That gives a position. And then I can again change this value to say 20 just to make it look nice. So this is all of the positional constraint and the length constraint that we do. So in order to do an angle constraint, you would actually need another line. So let's make sure we draw another line. Just assume it's coincidental at this point, and then you do again. So we are doing the smart dimension. So for this, I would select the first line. So it says maybe it thinks you want to probably do a line. Now if I select the second line, it converts that to an angle. Now if I click, it gives me the option of changing the angle. So because I've fixed the first line, if I change this angle, the only thing that I can change is the orientation of the second line. So if I maybe made this 25 degrees, the second line kind of like reorients itself to here. And then now I can potentially change some aspects of this line. So the only thing I can change is the length. So what I can do is, again, the smart dimension, if I did this, um, so I get smart dimension again. So it's not doing the length, so I can select these 2 points, and then this does the distance between those points. I can make this 100 if I wanted to, and so it changes the angle here. So the other one is the positional constraint. So for instance, I set the distance of this point from here to be 100 and the height to be 20, right? So I can, if I wanted this point to lie exactly here, one way I can do that is basically set this to 0 and then set this to 0. I double click on this and then I set this to 0, and that ensures that the point is exactly aligned with that origin over here, which could be potentially tedious because you might have to make multiple or lot of constraints like as such. So instead what I can do is I can delete this constraint over here, and then rather than specifying the dimension, I can just make this point to coincide. So the way I would do that is hold Control and select both of the points. So now it gives me the different options. Do you want to make it horizontal, where they're basically both on the horizontal axis? I can make it vertical, where this point would kind of get dragged here, or I can make it coincidental. So notice that as soon as I moved my mouse, I lost the context menu, but you don't have to fear that, because the context menu kind of is still available here. So I just make it coincidental, and then now this is kind of achieving the same objective as kind of setting those dimensions to 0. So if you refer to the notes, the other one we talked about was making lines collinear. And so let's do this. So maybe I select this line and this line. So I make it collinear, which basically has just oriented this line exactly here. So I can't quite see, so I can maybe move one of the endpoints a bit. So now this is a collinear constraint. So notice that it gives me the dotted line saying that this is actually collinear constraint. So as we are doing this, you would have probably noticed that there are a bunch of green rectangles that show up. And if you really look through and then kind of like, actually if you zoom in, it just changes the scale. But if you kind of like looked around this, you'll notice that if I click on it, it tells me what type of constraint it is. It also has a number associated with it. And so this is basically saying, oh, you basically set a collinear constraint between this line and this line. So now notice that if I can't really move this line. So instead, if I click on this box and then hit delete, I've actually deleted the constraint, and then now I'm free to actually move this point any which way I want. So while we're at it, we'll look at the second constraint. So we can make it parallel, which kind of is a subset of collinear in the sense you're not making it this line exactly oriented. So if I make it parallel, so I kind of make this as such. It also gives you all the other things you can do with two lines. So you can actually make the lengths equal. So then this is exactly 100 and so on. And we looked at the parallel from the geometry. And then what you can also do is you can make lines perpendicular to each other. So for that, let's do another line. There are a couple of ways you can do or impose the constraint. So I can kind of create the constraint and then kind of I can create the line and then add the constraint later on. But if I'm actually really careful, I can kind of start and then kind of orient it very close to the perpendicularity. And then notice that there is a yellow line that comes about, and then it is already or rather automatically imposed a perpendicular constraint. So it made this point coincidental with the line, and then it also made the lines perpendicular. The other one, for tangent, you need two entities. So one of it needs to be a circle. So let's do a circle over here. The circle we chose is a center point circle. We can also do 3 points where I select 3 points and then allows me to create the circle. So based on the 3 points, so the circle will be created. So if you remember the rules of geometry, if you have 3 points, you can only draw one distinct circle through it. So let's do this. And then now let's say I wanted to make a tangent line, so I created this arbitrarily. And then now I select this line and this circle over here. And then the option I have is to make them equal length, or I can make them tangent. Let's do tangent first. So it's done that. So let's do that equal length. So now what it's done is I think it's made the circumference equal to the length over here. So that's that. And then you can actually make this line also tangential to this circle over here. And so then if I notice that if I move the circle, the line stays tangential. So you can actually move it outside as well. And then it still stays tangential. So tangential is essentially like a touch constraint or touching constraint. So then notice that I can actually move all of these sketches. So instead of making one of this coincidental, what I can potentially do is maybe select this point and then fix the location. So if I did that, I can move this circle, but I cannot move the location of the circle. I'm still free to change the length. Because of the length constraint, all of the other things move as well. So it just makes it a very, very funny and interesting kind of a or drawing over here. So if you go to the next page, so you'll notice that there is something called as driven and driving geometries or dimensions over here. So let's see what the whole thing is about. So imagine I have this line over here. So I've basically applied some bunch of constraints here, right? So I said this line needs to be exactly equal to here. So let's see if I click and then give a dimension for here. So maybe I want to make this 25. So this adjusts the whole thing. So now if I try to do the smart dimension for this, so now it gives me a warning. So what it's actually saying is, because I've already defined this circumference from the radius, I can't again define this length. The only thing I can do is make it a driven dimension. So leave it as a driving dimension, give me an error. So I'll keep it as, make it as a driven dimension and then say okay. So now if I made this from 25 to say 30, where the circle will become bigger, you notice that this also has become larger. So it's automatically updated the number as well, where the dimensions change and the number gets updated. So let's look at the first of our 3D operations. So the first operation we're going to look at is known as extrusion. So think about in the morning, so hopefully you are brushing your teeth. So you remember when you squeeze your tooth paste, what happens is you basically are extruding the paste, and then the paste basically comes in the same shape as the nozzle that you have. You may not have, too many people don't really have like a square nozzle for the paste, but we can conceptually think of having, if you had a square nozzle, so instead of the paste coming in as a cylinder, it's going to come in as a square shape, and then if you have a triangle, um, and then it's going to come out as a triangle. So you can essentially extrude the shape to any length that you essentially want, and that's kind of what we do with the extrusion operation in SolidWorks. So essentially we kind of take a shape, and then imagine we're just like pulling the shape out of the sheet of paper, and then we pull the shape in the third direction, or we extrude the shape. So essentially if you had the rectangle here in the kind of the 3D view, I can just pull it out of the plane, and then I'll form the um, I'll form this cuboid over here. So to illustrate, so let's see how this goes. So if I kind of switch to my SolidWorks here, let's maybe do a new, and then maybe let's do this in the right plane, and then normal to view. So just for example, so we're going to do the corner rectangle over here. Then that basically is going to make that particular shape. So once we have this particular shape over here, so what I can actually do is set all of the constraints that I actually want. So let's move this shape around. So notice that the way I created, one of the constraints is already set automatically to the origin over here. And then what I can do is essentially add some smart dimensions over here. So we call this 50, and then maybe call this 75. And then we say okay here. So now you have the sketch 3. So if you wanted, you can rename this sketch to anything you want, and then we can basically extrude the shape. So notice that if I select the sketch over here, it gives me the option to edit the sketch, and then if I and then it also is giving me to option to suppress and do all of the other stuff. And then what I can do here is click on the features bar over here, and then if I say extrude, it's going to pull the shape out of the plane, right? So similar to what we discussed. So on the side over here, so you have all of the options that are available. So it kind of gives you like a detailed preview over here, but you'll focus on the other stuff here. So the first option it says is from, so that tells me where, from which point the extrusion begins. So instead of it starting from the plane or the sketch plane, I can actually select all of the other planes. So if I had another plane parallel to the sketching plane, I can start from that particular plane. I can similarly have start from a vertex, but since we don't have any other reference surface, we're going to click offset and then like randomly increase this. So this is our sketching plane, and then our object has basically started 20 millimeters from that particular plane. So that's based on this number that we set. So the next one is the direction 1, which is like how far we are extruding in the first direction. So this says is blind. Instead of blind, you can drop down and select up to vertex, up to surface, offset from a surface, up to a body, mid plane, and all of these options. So these kind of tell you how the extrusion is actually created. So for now, we're going to, again, since we don't have any of the other surfaces or vertices, we are going to click blind and then just give it a distance. So maybe let's make this 20 or 30 millimeters. So this has gone in this direction. And if you wanted to flip the direction, so you can actually flip and then have the extrusion go the other way. And then once we have the first direction, we can enable the extrusion in the opposite direction as well. So in this case, again, it's blind by 10 millimeters. What we're going to do here is give a draft. So what do we mean by draft is we are basically giving a small angle to the extrusion. So here I'm making it larger so that you can actually see. So right now I've given it as 9 degrees. So the advantage here is if I can actually have two different drafts in either direction. So I can basically make this go this way. You can actually have the draft go in the opposite direction, which is called an outward draft. So typically you would have an inward draft. So the reason you would have an inward draft is when you're actually manufacturing the part and then you were, say if you're casting the part, then it's useful to have a slight angle so that you can actually pull the part. So imagine your cupcakes that you actually buy. So if you're baking the cupcakes, you actually have a taper on it, so which would conceptually be the draft. And so then you can actually take the cupcake out of your baking oven or a baking tray. I know, I know baking isn't the most relevant thing you would think about in an engineering drawing, but nonetheless the principle actually applies all over. So that's what we are doing. So we can actually give like the draft in either direction and then change the values. So once we do this, we can say okay, and then this is the part. So now notice that the sketch has gotten hidden. So we want to change the sketch, you have to drop down and then click. So some of the dimensions will be visible here that you can actually change. So for instance, if I click instead of 50, so let's make it 75, is significantly bigger. So now notice that it's become like the cross section has become squared, and the entire shape is actually updated based on that. So the other things we want to look at is instead of extruding it up to a particular or rather by a particular distance, we can extrude it up to a particular reference geometry for which we need to create a separate plane. So in order to create a reference geometry, I'm going to create one plane which is parallel. Since my sketch was created in the right plane, so I'm going to create another reference geometry parallel to the right plane. So what I would do is click on the right plane and then click on reference geometry and plane. So you don't necessarily have to do it in this order. If you just randomly clicked on plane, then it will ask you more questions regarding the references and so on. Rather, if you started by selecting this plane and then select the reference geometry, SolidWorks will interpret that you probably want to create an offset plane, and then it gives you the different options here. Actually, this would also show up if you just created the geometry as is. As soon as you select the first reference geometry, it will kind of to give the option. Anyway, so once we do this, we can give the offset distance. I can flip the offset direction where it goes on the other side. Now I go up to here. So we have gone up to 60. You can actually adjust these values. You can actually create, because we just have one plane, so it's going to be at a particular distance from my right plane. If I had two planes, I could create kind of an angle and do more complicated stuff. But for this particular case, we're going to leave it as an offset plane and then just select OK. Now, this is going to illustrate two parts. So the first one is if I now try to end this feature, you'll notice that my plane has gotten missing or has gone missing. So the reason this has happened is because of the way the SolidWorks, like the creation is structured. So what SolidWorks does is you're actually building your elements on top of each other. So what it thinks is that the plane has been built on top of the extruded part, and so once you try to edit the part, this isn't actually available. So what we do in that case is we can actually move the um, the plane one that we created anywhere above it. So you can't move it above the right plane because it needs the right plane as reference, but you can move it just below the origin over here. So now if I edit, essentially what we're doing is we are rewriting the history, or if you think about in a kind of weird way, you're actually taking like a second floor and then trying to put it under the first floor and then kind of like restacking the whole building so that you can use the first floor as a reference. So now if I go back here and then select edit feature, now instead of blind, I have the option of saying up to a vertex or up to a surface, and then I can actually select this surface, and now based on the distance, it gets updated over here. So as before, if I wanted to change the geometry, I can, like if I wanted to change the cross section, I can do it on the sketch, but this is basically being controlled by the plane 1. So if I edit the feature, so instead of plane 1 being at 60, if I made it at say 65, let's maybe make it larger so you can actually see. So we make it 100 and then say OK. So now, and then we say everything gets automatically regenerated here. So that's the advantage of using kind of like inbuilt, and then if you're using the distance as a constraint, everything gets automatically generated over here. So there is some space at the bottom of this page so if you wanted to kind of create nodes. So the same thing applies for the other case as well. So this is a very simple extrusion where you just had one rectangular shape. You can change the value of the shape. It could be anything you want. So we'll look at a slightly more complicated example where we're trying to paste on top of the object. So this would be an example of creating an L-shaped object here. So we are going to try to do this in multiple ways. So the first way we're going to do is kind of proceed with the extrusion that we've already done. So where we're going to extrude and then try to paste another extrusion on top of the first extrusion. Right, so in order to do that, what I'll do is I'll extrude the object first and then create another second sketch on the extruded face here. And then what happens is you can actually kind of like you're thinking about sticking it here and then you're extruding it further out. So you're essentially kind of maybe the laser pointer looks better. So you're basically going to try to stick this face here and then extrude it further. So let's see how that works. In SolidWorks here, so we have this. So maybe let's kind of rewind the shape and then reuse or recycle the shape. So we need to be nice stewards of the environment, so we'll recycle our shapes as well. So then here, let's edit this one. So here, maybe we don't want the direction 2. So here we just extruded up to, like, so this one is offset, and then we just say okay. This is just an example, right? So that's fine. Maybe I don't really, I can leave the angle or the draft. If I didn't want that, I can remove that as well. But nonetheless, let's keep it. So now I can actually create the sketch in one of two places. So what I've actually selected now is the face of the extruded surface, right? So this is different, and then I can similarly create the second sketch on plane 1 as well. So either would work, but now I'm going to just create it on this particular plane, and then we'll say right click here because it's a plane. It gives me the option of creating a sketch on that plane. And then now again I'm going to go orient to view, and let's create a rectangle over here. So now as soon as I take it to this point, it constrains it there, and then takes it to this point, this gets constrained, and then we say okay, and we right click here, excuse me, we select the sketch and then say extrude. So now we can't really see, so I'm going to rotate by my mouse using the middle key. Again, I can give a blind distance over here. Um, Again, I can go up to a vertex, up to a plane. So right now, just let's do it about 40 millimeters, and then let's say okay. So now if I can reorient my view, so if I go Control 1, I'm going to show you some illustration of what can happen. So now if I basically went ahead and so I can't actually edit this particular shape from this view. So you can select this and then maybe I make this a little bit smaller. Right? So instead of this, if I made this say 60, so my sketch would automatically get updated, and then all the corresponding parts will also get updated. So this didn't make a big difference. So right now it hasn't actually rebuilt the surface uh, or rebuild all of the objects. So what I'm going to do is hit Control B, which is to rebuild, and then now you notice it's actually changed the shape. So the thing that happens here is if I actually change, say for instance, the edit this feature and then change the angle of the extrude, which is going to affect the position of this vertex over here. So if I basically remove this and say okay, so notice that the hum gets automatically shifted to the correct location. So you can actually do more complicated stuff using the extrude. So you don't just have to do like a simple extrude. So we look at a couple of other ways. You can actually do the same shape, like essentially like extrude the same shape. So for the L shape, the easiest way would be to essentially kind of like look at an actual L shape and then extrude it. So if you're looking at the XY shape, you can extrude it along the Z direction. So the other way to do it would be to actually create two different rectangles on a single plane and then extrude it up. So let's quickly look at those two ways of essentially doing the extrusion. So here we go. So let's pull up SolidWorks and then so here we go. So maybe we'll start a new SolidWorks part again just to make it a little bit cleaner. So this one we're going to look in the XY plane. So let's do both of these methods and then compare how easy or difficult it is. So here this one is going to be more easier. So in order to create the L, so what I might actually do is start at this point, uh, and then notice that it already puts a vertical constraint, and then go a little bit along the X, and then like so, and then notice that it automatically aligns it, and then now we have actually formed the L shape. So what I would typically want to do is dimension these. So I'm going to assume this is about 20. So this is also 20. And then we can assume this is either 20 or 30. We're just creating an L shape, so let's make this 30. And then this height is also 30. And now the sketch is what you call as a fully constrained sketch. And then we go out, and then we take the sketch and then click on extrude, and then we can extrude it how much ever we want. Let's just say we're going to extrude it by 20 and then say okay. So save this. We can typically we want to save this, but now it's okay. So we'll hide this part for now, and then we'll create the shape on the top plane. So I'm going to go sketch and then normal to view. So we're going to create the two rectangles. We can do it in many ways. So the easiest might be to actually create one rectangle and then create kind of another line like so. I purposely create this at an angle, and then I can basically constrain this to be vertical. What I can do is add smart dimension. So this would be the total. So if you wanted to get the same dimension, so that was about 20 plus 30, so this would be 50, and then this would be 20, and then this would be 20 as well. So from here to here would be 20. So I don't have to create these in two separate sketches. I can actually create the whole thing in one sketch. So this is actually going to illustrate another thing that can be done in SolidWorks. So we'll see that shortly. So I'm going to select. So notice that unlike the previous attempt, SolidWorks did not actually give me a kind of a rendering of the image. So the reason being, it was unable to figure out, because there are two different contours, it was unable to figure out which one I actually want to extrude. So let me select this close contour over here, and then the height here I might want it to be about 50, and then we say OK, um, and then say OK. So you can just go into the 3D view, or I can hit Control 7, and then that will give me this view over here. So then, so notice that my figure went away. So it's not gone too far. It's actually hidden, or kind of it goes inside this object. So what I'm going to do is actually use this drop down here to open up this object, and then click on sketch, and then do extrude again. And then now I'm going to select this region. So this height I probably want it to be about 20. So 20, and then say OK. And then this basically creates the shape. Right, so you can actually compare it if you want with the previous example that we had, and then convince yourself that both of them look identical. Okay, so now would be a good time to pause the video and then think about how you might actually create this table over here. So this table, so you can think about the different ways in which you can actually create the table. So this might potentially be, if you think about it, like a design problem, and there isn't just like one correct answer. So there are different answers, and they would potentially have like different merits. So one might be better in some aspects, easier in some aspects, and so on and so forth. But you don't really have one correct answer to this particular problem. So keep that in mind. So pause the video, and then you can kind of enter the answers in, and then we can you can resume the video, and then we will kind of do this together. So let's see how we can actually do this. So we are going to look at creating this video in a couple of different ways. So we are going to try to see if we can actually create the object on the XZ plane, which would be the top plane, as well as create it on the side, actually XY plane, and then see if we're able to do the extrusion. So we generally want to minimize the number of sketches, so that's kind of not strictly necessary, but then it just makes life a lot easier. So let's see if we can do that. So on the top, if I wanted to create it on the XZ plane, so what I can actually do is create a rectangle or a square in this case for the top, and then I'll create 4 different squares for the legs. If I wanted to do it on the XY plane, so that's going to be a little bit more challenging, and then we'll see how that actually works. So let's do a new part. So we were basically going to create this on, it says on the top plane, which is also the XZ plane here. So I'm going to go and then create a new sketch. So I can, if I wanted, I can center my table about this point. So for that, what I would do is kind of create the center rectangle. I don't want it to be rotated, so I'll do that. So I'll click the center point over here, and then click. So we aren't given the dimensions on the problem, but normally for a design you need to know that. So let's click. I'm going to assume this is about 100 millimeters each side. So we go 100, 100. So once we have these two, so then we can create rectangular legs. You can create that in a separate figure. That might actually make it a little bit easier in this case. So again, I click on the top plane, and then I can click on sketch. And then here I'm going to create my center, or I can actually do it on the edge corner rectangle. So I can choose this to be one of the corners. Since I want it to be square, I can choose this and then set the square as one of the constraints. So let's zoom in here. I'm going to select this guy, and then make them to be equal. The other option would be to make this line and this line perpendicular, which would kind of achieve the same objective here. So once you have that, we can give a dimension for this. So maybe we call this about 10 millimeters. I could have, instead of giving the equality constraint, I could have made this line and this line to be both equal to 10 millimeters. So it will kind of do the same thing. So here we will try to do something slightly more interesting. So let's see, this is fairly self-explanatory. So let's see if we can use one of the other ones here. So notice there is something that says it's a linear pattern or a circular pattern. In this case, you could use either one of those, but let's do a linear pattern here. So then it's asking me how many I want in the X and the Y direction. So I'm going to basically want to move this. Actually, maybe the circular pattern is easier. So in this case, I would actually move it by 100 minus 10. So I would basically move it by 90 degrees. So I only need one copy here along the X, one copy here. So I'll make this 90. Oh, okay. I need two copies actually. So I'll make this 90. And then here is asking for the entity. So I'm going to select all of these. So I'm going to select this. And then select OK. So now it's actually created these four copies, actually three copies and one original here. And then if you notice, if I make any changes here, so for instance, if I made this from 10 to say 15, you'll notice all of them actually update. So the only problem based on the way I've sketched it is because I've set the distance from this node to this node, if I change the dimensions over here, the spacing of the leg kind of changes. So if I wanted to avoid that, what I could actually do is if I created a circular pattern about this point, then the rotation would be a lot nicer, and then it will not kind of like move if I change the, or rather if it will not kind of go outside the table if I change one of the dimensions. So for now it's okay, so I'll undo this. So this looks good, and then I say okay. Then let's do Control 7. So we want the tabletop to go up maybe. So let's do click on that and say extrude. So this is looks like it's set to 10 millimeters. That sounds good. And then we look at the other sketch, and then we extrude. And so this, we don't obviously want the leg going into the table. So we're going to flip directions, and then maybe we'll make this about 100 millimeters. And then we say okay. And then this basically creates a table by sketching on the X, Z or the top plane. So let's save this. Then maybe P1, do one more new part. And then we're going to create the table by sketching on the, you can do right on the front plane because the symmetry doesn't really matter. So let's do it on the front plane. So we're going to go sketch, and then we have the rectangle. So in this case, it's going to be a corner rectangle. So I can click, I don't actually click, move my mouse very close. And then if I can maintain the constraint over here and then do it as such. So zoom in. So what I'm going to want to do is click on this point and then this line, and then see if you get something more interesting. So there seems to be like a midpoint constraint over here. So let's click on the midpoint and then see what it does. So you notice that it's now symmetric about the origin over here. So now I can give the dimensions and make it look a lot nicer. So this, maybe I want it to be, keep the same table, it's 100 millimeters. And then this is going to be 10 millimeters. And so that is my table over here. I can create the sketches for the legs here as well. So let's do that. So the easier way to do it would be to do rectangles again. So here, and let's call this here. And to make both of these lines equal, there are actually multiple ways I can make the two legs equal. So one way to do it would be to select this line and constrain them to be equal. So which would basically mean that my legs would be equal in size. The other option would be I can actually select the bottom two lines and then make them collinear, which will again make sure that the two legs are always aligned. So this again depends on your design objective. Uh, while drawing, it doesn't really matter. But if you think about how you'll actually manufacture this part, you're probably going to take all four of these legs and then cut them to the same length. So it might makes more sense to actually select this one and then try to make them equal in length. So this is constrained now. And so now if I change this length, the other leg goes along for the right. So let's select the length, and then this we want it to be about 100 millimeters, and then select OK. And now this is the correct length. So this comes out OK. And then now we are going to exit the sketch over here. And then what I can do is I can extrude. So select this, and then now again it doesn't know which shape. So I'm going to select this contour over here. If I want it coming out, I can leave it as is, and then there's going to be 100. And then the table is done. Top of the table is done. So we're going to select again and then select the leg regions. So this we want only to be about 10 millimeters. And then set the value to be 10 and then say OK. So what I can also do is select the sketch again and then say extrude. But now I can do a couple of ways. So let's do offset from the, or maybe we'll kind of like from a particular surface. So this is sketching plane, so we can go from face or surface. So I can select this and then we can give a blind and then give a direction. And so you notice that there is going to be some, let's see what it actually does. It's going to give us some problem. The reason is the face here is very small and the sketch doesn't actually intersect with this particular face. So this is not allowed. If you really wanted to do that, what you can do is we can create another reference plane over here. So we can do select here and then we'll create a reference geometry which would be a plane and then we can make it coincidental and then say okay. So the visual of the face can be changed by dragging these little limiters. So then if I select the sketch and then extrude, what I can do is instead of from the sketching plane, I can select plane and then select this plane over here and then like flip the direction and then go 10 millimeters. I need to select these two contours and then select OK. And then now my table is complete. So this isn't the only way you can actually do this table. So there are probably like several other ways you can do it. You can actually examine what's known as an extrusion cut and then see how that actually works out for this particular table. So that is very, very similar to the extrusion and then it's actually located just beside the extrusion. So if I pull this in here, SolidWorks, so instead of extrude, you can actually do extrude cut, which is kind of like very close by. And in this case it's actually going to cut and then remove material. So you could kind of like have created this particular face for the whole table and then cut this region and this region out. So that's another way you can do it. This would be like if you're thinking about actually machining a part, that will be the workflow that would have been employed in that case. So coming back, so we are going to look at a different way we can create the same thing. So here we go. So essentially, we created the different ways for creating the table over here. So then let's look at another example. So this is known as a revolution. So this is really useful when you're creating axisymmetric shapes. So for instance, if I wanted to create this particular, like this spray bottle, so I can actually create an axisymmetric shape, and then this is symmetric about this axis in the middle. So in that case, or if I think about this pen without the cap, I can again create it by rotating about a particular axis. So this, for this, I would use what's known as a revolution over here. So for that, how does it work? So let's do another part. Let's do Control N. And we would create this particular part. So maybe let's create this at the front plane over here. So for that, we're going to create a rectangle. And like so. And then we give some dimensions to it. So we'll call this maybe 60. And then we'll call this 20. And then click enter, and then we have the particular shape that we have, and then once we have that, now we can actually rotate it about a particular axis. So we say okay. Oops. So I can say close the sketch, and then we click and then rotate it about a particular axis. So here it's giving everything that you would need. It says what axis do you want to select. So I can actually select this point inside and then create, and then I can do it by 360 degrees. I can do like a second direction where you would rotate maybe like 90 degrees in one way and then maybe a different angle. So if you wanted to create a whole circle, you would need to do a total of 360 degrees. So think about how you can actually create this if you wanted to create a hole in the middle. So just think about it and then pause the video and then come back, and we can think about how we can potentially do this. So it depends on what hole you're looking for. So this is the revolution that we had. So then the question really is, what is the kind of hole you're looking for? So if it's a circular hole, so what I can actually do is, if I select, okay, this created the shape, what I can actually do is if I edit the shape, and then imagine I add another line over here. I'm going to purposely, just for the fun of it, have it oriented in an arbitrary direction, and then say okay. Okay, didn't like try to build a sketch. So let's edit this and then see what actually happens. So the reason is we need to select this contour over here, and then the axis. Let's see what happens if we select this particular line. And so we kind of create some fancy funnel looking shape. Again, what's actually happened is we still have the rectangle, but then we have rotated it about a particular axis. So you can actually rotate this by middle clicking and hold and drag, and then see how this actually looks. So it depends, again, as I mentioned, on what kind of a hole you actually want. So let's switch back here. And then if you wanted a different hole, let's see how that actually works. So in this particular case, so let's see if you wanted a square hole. You can't really create a revolve and then create a square hole. So there are only a couple of ways you can actually do this. So one is to actually create everything on the top plane or the XZ plane, and then you can just do like an either extrude or an extrude cut. The other way to do it would be to actually do the revolve for this particular shape and then do an extrude cut for the rectangle over here. So let's see how that might work. So going back to SolidWorks here. So let's see. Let's maybe just reuse the shape. So edit this part. And what I can do is select this face and then create a new sketch. And then create parallel to sketch. And then if I wanted to create a rectangular shape or whatever shape I want it, I'll say okay. And then this is where the extrude cut comes in. So I go extrude cut and I need to move this around and then blind. So here there are different options. So you can either give a distance or I can say just cut through everything. So let's give a smaller distance, maybe 5 millimeters over here, and then say okay. So then it kind of creates an extrude cut here. And if you're actually doing this part, manufacturing it, you can't actually create that sharp an edge. So you can actually use this feature, which is a 3D fillet. It just makes the surface nicer once you're done with it. So the next shape or next function we're going to look at is known as sweep. So sweep is actually useful when you wanted to create some arbitrary shape. So essentially you could take kind of like a rectangle and then move it and deform it in any which way you want. So here there are three main components that go or are required to create the sweep. So the first one is the profile, which is the shape that's actually getting swept. The second line or the second curve is the path. It's the curve or the direction in which the profile gets swept. And then finally we have optional guide curves which allow you to kind of like deform and twist the shape if you wanted to. So we would now switch to the SolidWorks and then see how this actually works. In order to get the profile to work, we're going to use something known as a like a Pierce constraint. The profile, this doesn't work without actually using the profile constraint. So let's see how that actually works. So switching to SolidWorks over here. So I closed all of the windows in the meantime. So let's do new, click on this. So the order I basically recommend is for you to create the path and then the guide, and then you would create your actual profile. So the order between the path and the guide doesn't make too much of a difference, but you want to make sure that your profile is always created at the end. So let's, if I wanted to create the same shape as I wanted there, let's say I wanted to create essentially on my front plane. So let's create the shape. So I'm going to make sure I'm not going too crazy here. So maybe just a little bit here, a little bit here, and then hit escape and then exit. So next I want to create essentially the guide curve, right? So I want to make sure that the shapes maybe twist a little bit. So maybe we'll create the guide curve on the top plane and then see if it actually works. So let's create this curve. So again, we don't want to get too carried away. Like so in here, and then hit escape and then exit. So now we have two shapes. So let's just basically name this. So we're going to call this the path, and then we call this the guide. And then I'm going to create my profile on the right plane, which is going to be here. So let's sketch. So I'm going to use maybe a center rectangle, like so. And then what I'm going to do is select this point and this curve. Make sure you don't use a coincidental constraint. I'm going to use a Pierce constraint. And then what I'm also going to do is select this point and this curve, and then we're going to do a pierce constraint again. So it just doesn't want to do a constraint. The reason being there is this horizontal constraint over here. So let's maybe just delete these constraints. And now we're able to do the pierce constraint. And then maybe we just want to make sure it doesn't get too haywire. So we wanted to minimize the twist. Maybe I can make these two perpendicular. And maybe this and this perpendicular as well. And this perpendicular. So this will ensure I'm keeping a more or less rectangular shape, and then we are going to do the sweep now. So for that we have to go back and click on sweep. So we're going to use this as the guide. So we do sweep, and then it's asking me for the path. So I'm selecting this. So it looks like it's created the shape. So let's actually see what happens if I select the guide curve over here. So notice that the guide curve is kind of like guiding the shape. So because of the way I've set it up, the shape actually rotates and the guide curve kind of like guides some of the points on the shape. And then I can actually create a more fancy looking shape. Again, so this would take a lot more effort to get to the actual shape that you want. But nonetheless, this looks fairly interesting, and then this is kind of useful if you wanted to create more complicated shape. So the next topic we're going to be looking at is what's known as direct modeling. So this is where instead of creating sketches and then extruding and doing all of those, if you happen to already have a model, we can actually move just some of the faces, kind of like tune, deform, and do all of the fancy stuff. So I'm going to demonstrate really simple direct modeling steps, but you can actually go through all of the steps and look at more complicated features. But for here, we're going to stop at just the simple ones. So we're going to directly move the faces, and then we're also going to use patterns to kind of like make copies of the object. So the other ones, I encourage you to kind of like take a look and then see how that actually looks. So I've opened up this model already. So let's see if I can actually do a direct modeling of this face. So I'm going to click on this face. So if you remember, I said insert, and then you go to face. So here is where all of the other options are there. So for now, I'm not going to do any of those. Rather, there's actually like dome and all of that stuff. I encourage you to take a look. But here we're going to go to insert and then face, and then we're going to say move. So here, because I selected the face already, that's highlighted in blue. So here, if I wanted to just translate it, so it says which direction do you want to translate. So I'm going to select this line to give it an axis. So I don't want it to go down. Maybe I want it to go in the other direction. So flip, and then it starts moving up. I can increase the distance and then say OK. So maybe select this new face again, insert face. Let's see if we can do something else. Move. Maybe let's see if we can actually rotate this. So here face, so I need an axis. Obviously it makes sense to kind of rotate about this axis over here, and then select this, and then maybe give it a couple of degrees and then see what actually happens. So maybe we flip directions, and then now it's kind of like going up, and then we say okay, and then now we have actually directly moved all of those faces. So then we are going to look at the pattern. So notice now we are in the feature mode. So we have the pattern in the sketches, but you can kind of do the pattern in the 3D as well. So where you can do like a linear pattern or a circular pattern, and then you can mirror, do curved driven patterns, sketch driven patterns. So you can kind of take a look at this and then see how this actually looks. But we'll do the simple linear pattern for now. So the first thing is asking for a direction 1. So I'm just going to use these lines here. So I'm going to assume this is direction 1, direction 2, maybe along this direction, and then the body that I want to select, maybe just this guy. So I'm going to select all of this, and it says how far do I want to move it. So this is, maybe I want to move it by about 100. This is going to give me a preview. 100 is probably not enough. Maybe make it 150 so that I have enough space. And then along here I probably need it, say 50 to 100. Let's do 100. This is along the two directions, so I have two here. I wanted four. I can do this. I can do more complicated stuff, so I can kind of like, instead of doing the whole body, I could have essentially looked at faces and then did that, and then I can look at skipping some of the instances as well. So I kind of ask you, encourage you to take a look at all of the other features, particularly like the circular pattern, curve driven pattern, and all of the other stuff. So moving on, so the next one we're going to look at is what's known as a helix. So the helix is kind of, you think about the spring, so what actually happens is it kind of is rotating at the same time it's moving along the axis in the z direction as well. So if you think about a football, so technically they're not actually throwing a spiral, so if they threw a spiral, the ball will just stay in one place, so they're technically throwing a helix. So next time you see a football player, let them know you're throwing a helix rather than a spiral. So that will be an interesting conversation, I think. Anyway, coming back, so the way we would define the helix is you need to have like a circle which defines the space in which the helix lives, and then you're going to define the pitch, which is the distance between any 2 points in this direction, or you can kind of figure out the total number of angles and do all of that stuff. All of that is going to show up once you do the drop down menu here. But the question is, how do we get there? So we are going to go click on the curve and then select helix, and then it's going to open up this menu, and then we're going to try to create our helix using the menu option. So let's see. So here is my SolidWorks. So let's do a new drawing. So I'm going to go curve, helix. So it says essentially you need to create a plane to which select, so you're going to select a circle. So maybe let's create this on the top plane. So we do this. We can give it a smart diameter. And then we say OK. And now I can actually go to Control 7, and then it will show you kind of the correct orientation. So now I've set it up to pitch and rotation. I can give height and rotation, pitch and height, or if it's a spiral, these options don't apply. So maybe let's keep it at pitch and number of revolutions. So maybe just have few more, maybe 5. And we can do the pitch a little bit smaller, maybe 25. So a little bit more compact. You can select clockwise or counterclockwise. So counterclockwise, and then you can give the taper if you want it in degrees. We're not going to do that now. So now we say OK. So we have this helix over here. Now if I wanted to create a spring, so what I do is I select this curve, and then I'm going to create a reference geometry, create a plane. So the second reference, I'm going to use this end point. Oops. So make this perpendicular. So my second reference, I can select this point over here. For the first reference, I can select this curve. So then it's going to make it perpendicular. And now we're going to say OK. And then on this plane, I'm going to create a circle. Sketch. Oops, I edited. I'm going to sketch and then parallel. Then make these coincidental. So we can do a Pierce constraint here, and then we click on this, and then I can actually sweep along the curve over here, which will create my spring over here. And so this is how you would actually create a helix, a helical spring. So the next topic we're looking at is known as holes. So the reason there is a special function available for holes is because if you think about a lot of the assemblies, you have specific holes in them, you have threads and all of that stuff. And if you were to actually construct all of this by hand, it's going to be fairly difficult. And so we would essentially use the standard feature. So essentially we have standard sizes, so we can match the drill, and then it has a conical tip. You can also do simple threads or holes without thread, which would be through holes, and then if it goes through the object, it's known as a blind hole. And then you can have thread, which is be the standard thread based on the size that you actually select. And then you can also use the hole wizard feature, which kind of allows you to quickly do all of these standard versions. So on the next page, we'll cover that as well really quickly. So I'll click on the hole wizard, and then this will open up the dialog box over here. And then you can select the position where the hole is going to be created. And based on that, you can create the hole itself. So you can actually create multiple holes really quickly. And then you can also create, there is an option to create threaded holes. So if you look at one of the options, you'll notice that it's actually a threaded hole. So let's see how that works. So let's open up the previous part that we had. Maybe we click one of these, and then let's see if I can actually create a hole here. So on this face, I want to create a hole, so I'm going to open up hole wizard. So it gives me all of the options for the holes over here. So I'm going to maybe use ANSI metric. I can give the hole size and then the type. So maybe it's an M5. So here is the hole type. So it's counterbore. Does it have countersink? So you'll kind of learn what these are later on in design courses. So let's just pick the, so this is one of the threaded holes. So let's select the option. So this is tap drill, and do you want it to be cosmetic thread, or this would be thread removed? So let's leave it at threaded, and then we're going to select the position here. So just center it over here, and we say OK. Then now it actually creates the thread over here. So if I wanted to actually uh, so you might notice that the thread doesn't actually show up. The reason is it takes, so if you wanted to show the whole thread, render all of the thread, it's going to take a lot of computer resources. You can actually show kind of like a visualization of the thread. So if you go to options and then click on document properties and then detailing, and then you can click on shaded cosmetic thread, and then what is happening is it's actually just putting a photo of a thread onto the surface, which is good enough for you to visualize and then see how it actually looks. So this is something you can actually do, and then where it creates a particular thread, and then you can also look at the other options that are there within on the thread to create different holes and different thread combinations based on the size that you do. We didn't discuss too much about the actual selection of the size. So those would depend on your application. So if you had a mechanical design, so you would kind of look at the strength that you would need for your bolt, and then based on the cross-section area and maybe what you're trying to secure and so on, that will kind of decide on how much depth, minimum depth you would need, and all of those details. So we're going to ignore that for now. So the final shape we're going to be looking at is what's known as lofts. So that allows you to kind of like transition between one shape and the other. So an example would be, so if you look at the inside of your ventilation system, so you basically go from a rectangle to potentially like a square and then maybe like an offset circle. So that's where lofts would be useful. And then in order to do the lofts, so you'd use the loft function. So you'd need to define two of those profiles, and then let's see how that actually works. So if you switch back to my SolidWorks over here, let's create a new drawing. Control N. Let's do the same thing. So we need two planes. Maybe create one more plane parallel to the top plane. So we have maybe 100 millimeters sounds good enough. So on the top plane, I'm going to create a sketch which is rectangular. Maybe center rectangle. So we're going to say exit. And then on the other top plane that we created, we're going to create a circle. So if you want, you can actually offset the circle. And then say exit. So if you go to this view, or if you Control 7, you'll see how it is. So we're going to go loft, and then we're going to select the profiles, and then the sketch 2 is going to be this guy over here. And then it creates, I can potentially add guide curves, and you can kind of like give start and end constraint about how the shapes will behave and so on. But this basically creates a lofted shape where you're transitioning from one shape to the other. So anyway, so this kind of concludes this video that we have, where we are focusing on an introduction to SolidWorks and kind of give an overview of the course as well. And this kind of we covered a lot of areas. So essentially from the basic, where you create like a simple sketch on a particular plane that you choose. Essentially remember that you're looking at a 3D shape, and then you're going to choose one of these three planes. So you can think about going to the corner wall, and then you're choosing on which surface you're going to create a drawing, and then you can like pull the object from that particular plane in the third direction, or you can rotate, or you can actually sweep, where you can create a more complicated shape. We also looked at transitioning between one shape and the other in terms of the lots. So this basically concludes our first week lecture, and then we'll see you guys again in the next lecture. Thank you.